Hi everyone, welcome to NetTech. I am Ganesh. Today we'll talk about LED blinking using 8051 development board. And the topics for this session is we'll be using a Keel microvision for creating a project, and I'll show you example for LED blinking programming. And I will be compiling and creating X file to dump into the 8051 development board, and dumping these X file into the development board using Norton ISP. Norton ISP is a flashing tool where we can flash hex file into the development board, that is 8051. And I'll show you overview of 8051 board with an example of LED blinking. So now we'll start with creating a project in Keel Microvision for LED blinking. So I'll show you the steps now. Once you open Keel Microvision, the window looks like this. Then go to project, new Microvision project. So when you click, like, you have to select a folder where you want to create a project. So I'll be creating a name for it, program LED. So when you create a project here, it asks for which board are you using. So we are using Norton board. In this, we have to select which IC we are using. The chip name we have to select here. The chip that we are using is W78 W78E052D. This is the name for the chip that we are using. Uh, you can see here it is 805 based CMOS microcontroller. So currently we are using this. So we have to select this for creating an hex file for this particular development board. That is a W78E052D. So once you select this, you will get a window like this. Give yes. So now project has been created. So now we have to write a embedded C program for LED blinking. So you need to add a C file here. So right click on the source group one, add a new item to group source group one. So then it will ask for which program you are writing, whether it is a C program or C++ or ASM file. So I'm writing in a C embedded C. So I am selecting it and I will be giving some name to it. Okay. So actually the file is already existed. So I will give another name. So now, yeah, C file has been created here, which is empty file. So now we have to write a code where we program it for 8051 microcontroller, where we are interfacing LED. So first will be like we have to include header file into that. So hash include h51.h is the header file for 8051 board. So after including the header file, so we have to declare a pin, which pin we are using it for LED blinking, that is S bit LED. So is it equal to, I'll be using a port one. In port one, I'll be using a pin 0. So the declaration is like this. So S bit means set bit. So we are giving a name for this pin, that is LED, which is equal to port 1 and pin 0. So next we'll be starting actual main function while main, so where we run this LED blinking inside an infinite while loop, while one. So now first I'm setting LED as 1. So now LED is on, and I'll give some delay where it stays, LED stays high for a certain period of time. Here 500 time units. And after this delay, I'll be making it as 0, which means LED off. Here LED on, LED off. So after off also I'll provide some delay. So now uh, the main function is complete. So now we have to create a function which generates a delay, a required delay. So I'll write a function delay signed int. So I'm declaring count as unsigned int because the incrementing value should be positive number, it's positive integer. So I have given as unsigned int, and I'll use a nested for loop, for loops, because I want more delay to be generated between LED on and off. So I'll declare two variables for loops, signed int I comma j. So first for I is equal to 0, I less than I plus plus. So I'll be adding one more for to generate a more delay. So for j is equal to 0, j less than, I'll use 500 j. This is just a random number. I j less than 500 is just a random number. So I'll just I've had it true false for loops, and I have to declare a function before definition. So void delay signed int count, declare it. So this delay function is to generate a required delay that is between LED on and off, that we are calling here. To generate this delay, we are using this function, and the main function is for LED on and off, which is running in an infinite while loop. So now, after compiling, we have to generate a X file. There are some settings where we need to add give some options for generating a X file. So right click on the target group one. Here in the target tab, we have to provide a frequency of the board that we are using. The frequency that the board that we are using is 11.0592 is the frequency, and the for the board that we are using, we have to set that. And one more is like output. Here we have to enable this option, create hex file, for generating X file. So then give okay. So now the setting has been done. So now we'll save and we'll compile. So we can see here that it has uh, compiled with the zero errors and creating an hex file. Here the hex file has been created in inside a folder with a name program LED. I'll show you where it has created. Uh, Inside object folder, yeah, this is the X file that we have created now, and we have to load this X file into the into 8051 development board using this is 8051 development board where it has 7 segment display, and it has a keypad for interfacing to the 7 segment display, or we can interface it to the LEDs as well. These are 8 LEDs where we can use for a LED blinking, and like we can here we can interface LED display. So in this case, like we are blinking LED, so we are using port 1 here, port 1 and 0th pin. So I'll be connecting port 1 0th pin to the LED. I'll connect it to the first LED, or we can connect it to any LED, but I'll use it for first one. So we can see that LED is turned on because connection has been established. So, and this board, this is the power supply, and this is UART connection, UART to USB connection to the where we flash hex file using Novaton. This is a flashing tool. So now I will show you like how to flash X file using Novaton tool. Here I have connected development board using COM3. So here COM port I have selected as COM3, and here I have to give the which board we are flashing, so that's why I am using W780-052D. This is the IC name, so I'll be selecting this name, and here we have to load the X file. In Keel Microvision we have created X file, so we have to load that X file. It is inside objects. So this is the X file which we have created. So I'll be selecting this X file. So once X file is loaded, we have to give a load chip. So when you give load chip, we have to give a reset so that the previous program will erase. So yeah, so this gives this window. When you click OK, so previous program has been erased, and new X file has been flashed into the board, so it has given pass. Now if you give OK, so now you can see LED blinking here. So now LED has been blinking. So now I'll show you the setup connection, where the 8051 microcontroller board is connected through UART to the UART and USB connection to the laptop, where we flash the X file using Novaton. So that's it about 8051 board and LED blinking with an LED blinking example. Hope you guys understood the concept, like how to interface LED in this session. Hope you guys like the video, and please subscribe. I'll be creating some more sessions for other embedded C programs like keypad interfacing, or a 7 segment display, or LCD display. Thank you guys for watching.